Okay, this is a January 2008 Excel exam. Okay, it's question 8, it's a C4 exam. This question is all about the volume change in the cylinder given a rate at which volume's coming in and a rate at which volume's coming out. Okay, so it's, and then we're looking at the height, getting the height of the liquid up the side of the cylinder. Okay, so the rate at which the volume's coming in is this, centimetres cubed, it's telling us its volume, and it's leaking out at a rate which is proportional to the square root, okay, of the height of the liquid already in the cylinder. So however high it is, we set the square root, okay, and that's the rate which is coming in. I've also given this bit here, 4,000, which is obviously, that's the area at the bottom of the cylinder, okay, 4,000, and the height here, h, which we're going to use quite a bit later on, and obviously we've got v, oopsie daisy, is equal to 4,000 times h. Okay, it's just basic equation there. So let's have a look. Okay, so as we've already said in the question, the rate at which is coming in is this, the rate at which is coming out is that. So post proportionality with just a constant there. Now the rate at which it changes in the actual container itself is always going to be equal to the rate it comes in minus the rate it comes out. Okay, if you think about that, you'll see it's always true. So we've got the rate that's coming in from here. Yeah, the rate at which is coming out from here. Okay, and we've got the volume, as we've already derived up here, is equal to this. So we're looking to get to, for this first question here, this statement here. So we're going to set up what we know about the volumes. It's a differential equation, which we've pretty much already done here. Okay, that's our equation there, really, linking those two. We're going to use this fact here that this is this. Okay, so if we differentiate this line, you can pretty clearly see we're going to get this line. Okay, because 400 is a constant, so you can just differentiate through. We've got the h, so we've got the h point, and then once you've differentiated through, I've substituted basically this, this for dv by dt up here, yeah, and then divided through by 4,000, alright, which gives us this. Okay, so now we're just simplifying down, boom, 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 get rid of the zeros, I don't really want to dwell on this too long, so we're at 1.6, and obviously, k is now divided by 4,000, so the new k I'm looking at is k dash divided by 4,000, okay? Okay, so the rate of volume exiting is this. Okay, so we need to read the next bit of the question there. So we've got when h is equal to 25, the water is leaking out of the hole at this rate. Okay, so the water is leaking out of the hole at this rate. So we're looking at this bit. Okay, so we need to take this over here and I'll put it equal to the 400 that we've found in the question. So root of 25, which is the height, yeah, is equal to 5, so we've got k dash times 5 is 400, k dash equals 80. What does that tell us about k? Well, we sub in from here, yeah, and do a bit of number crunching, and we're going to get k equal to 0.2. So we did have this. We can now put the value of k in that we've got from here, yeah, and that's going to give us the next step in the equation. Okay, so we divide through by 0.2 now. So we're looking at this next section. Okay, quite standard with differential equations. You find your physical phenomena, whatever it is, you find the differential equation that models it, and then you integrate it to start getting answers out of it. And that's what this next question is telling us to do. It's telling us basically to separate the variables and integrate this equation. Okay. So to get, you look here, they've got a 50 and a 20, and there's nothing in front of the root h. So the first thing we're going to do is to try and make our equation look a bit nicer by getting rid of these decimals. So we'll divide through by the 0.2. That's going to give us 50 here, 20 there. You can see that's just straightforward division. Now we need to split this up. We can do this in two. Well, yeah, we need to split this up so we've got everything in h on this side. Okay, everything with t over here, and everything with t. So effectively, it's just going to be 1 then, isn't it? So we can divide through by this, okay, and multiply it by that. And that will be in a form ready to integrate then. So we can integrate from 0 to 100. And t equals 0 to t is equal to 100, right? So here, when we integrated up, we got this integral was equal to, we'll put it in even, integral from 0 to t 100. T100 just means the time at which h is equal to 100, okay, of 1 delta t. Yeah, now you can see that's going to come to t, and that's going to equal that, so that's why that t 100 is there like that. Let's have a look at the next part then. So now the next part of the question is giving us this substitution to make so that we can actually solve this, alright? So we're going to put, when h is 100, we're going to get 20 minus x equals 10. Okay, because we've square rooted that, it's going to give us x is equal to 10. Similarly, h is equal to 0, 20 is equal to x. Okay, now we also need to get rid of, okay, we're going to, that's looked at the limits, we need to get rid of delta h as well. Okay, so we've got delta h, well, you just need to differentiate this. The 2 is going to come down, you get the minus 1 from there. Okay, so you get minus 1 there, and you get 2 there, and that's the rest of it. And there's the delta x. Okay, so we substitute in now. Okay, we substitute in. So, got a bit lost now. So we got, oh yeah, root h, which is coming in from here. Yeah. So root h is obviously just 20 minus x. We've got the 20 on the bottom of our integral from here, 50 on top, and this bit here is replacing the delta h going there. Obviously your limits are coming from there and from there. Okay. Okay. Now to get rid of the minus sign, if you flip the top limit and the bottom of an integral round, it's just equal to the minus of what it already was. Okay, so you might want to have a think about that, but it's quite a useful tip to have. So I'm basically using it, if I flip these two over, then I can get rid of the minus there. So I can do 2 times 50, take it outside, gives me 100. What am I left with inside then? Well, that's going to come to simply x at the bottom, isn't it? Because that's going to go with that, and the minus sign there is going to make it plus, so we've just got x at the bottom. That's where that comes from. We've taken these two outside. Okay, and we've just got the 20 minus x, then delta x at the top. So that's that step. Let's have a look a little further down. So now if we divide through by the x, we get 20 all over x minus 1 delta x. Okay, so I've just divided both the 20 and the x, both the 20 by the x and the x by the x, which obviously is minus 1. This is pretty simple to integrate then, isn't it now? Because that's going to be obviously 20 log x. Yeah, that's just going to be minus x. Okay, keep the 100 outside. Yeah, we do 20. And all we're doing now is just subbing these bits in. So we've got 100, 20, log of 20, minus 20, minus 20. Okay, this is what you get, so 20's gone there, isn't it? Yep, and the 10 goes in here. And we just subtract them, do the number crunching, yeah? There's not much to it now, really. We've got 20. So, yeah, we go down. And obviously, when I get to this stage, I'm going to just do 20 divided by 10, which is giving me my 2 there. Minus 10, that's the time in seconds. Obviously to get to minutes you divide by 60, and I'm not explaining that to you because I think I have no problem with that. So I hope that was helpful, and that's basically how you do the problem.